Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring dilations on the coordinate plane. Before we do, let's review a little bit about dilations and scale factor. So remember, a dilation is just a transformation in which a figure is enlarged or reduced with respect to a fixed point called the center of dilation. A dilation can be found by multiplying the original coordinates by the scale factor to get the new coordinates. When the scale factor is greater than 1, the figure will enlarge. When the scale factor is between 0 and 1, the figure will reduce. When a dilation has occurred on the coordinate plane, you can find the scale factor by choosing corresponding sides or vertices and find the ratio of the image to the pre-image. So I usually write that as new divided by the original. When we're finding the scale factor, I'm simply dividing the new by the original. So in example 1, it says dilate each pre-image by the given scale factor and then complete the requested information. In part A, we have a scale factor of 3 over 2, which is the same thing as 1.5. So because that's greater than 1, I know my new shape is going to enlarge or get bigger. Now what they want us to do is list the coordinates of my pre-image. So here's point A, so that's negative 2, 2. Point B was negative 2, 1, 2, 3, 4, negative 2, negative 4. Point C is 1, 2, 3, 4, 1, 2, 3, 4. So 4, negative 4. And point D is at 4, 1, 2, 3, 4. 4, comma, 4. Now, to enlarge each one of these points, I'm going to multiply the coordinates by the scale factor, which is 3 over 2, or 1.5. To put this in my calculator, I'll use 1.5 just to make it a little bit easier. So I'm going to take the negative 2 times 1.5, and that would be negative 3. And then 2 times 1.5 would give me positive 3. Now I'm going to enlarge the point negative 2, negative 4. Now I already know negative 2 enlarged by a scale factor of 1.5 is negative 3. Now let's take negative 4 and enlarge it by a scale factor of 1.5. So that would be negative 6. Okay. All right, now I'm going to take 4 and multiply it by 1.5, which would be positive 6. And negative 4 multiplied by 1.5 would be negative 6. And then 4, 4, that would simply be 6, comma 6. Now, what they want us to do is draw the image after the multiplying it by a scale factor of 1.5. So I'm going to get a different color here so you can see this. So A prime would be negative 3, positive 3, 1, 2, 3, 1, 2, 3. So I'll label that A prime. Point B would be left 3, 1, 2, 3, down 6, 1, 2, 3, 4, 5, 6. So here's B prime. C prime would be at 6, 1, 2, 3, 4, 5, 6, and down 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So here is C prime. And then D prime is at 6, positive 6. 1, 2, 3, 4, 5, 6. So here's D prime. Now I'm going to try it as straight as I can, connect these. So you can see our image has definitely enlarged by a scale factor of 1.5. Now, the way we write the algebraic rule is just take your scale factor, multiply it by x, take your scale factor 3 over 2, multiply it by y. Now, you could also write it like this, and that would be the same answer, all right? All right, problem B, we have a scale factor of 2/5. Now, because 2/5 is bigger than 0 but smaller than 1, this is going to be a reduction. So what I want to do here is label the coordinates of point A, B, and C. So point A, see, we're going right 10 and up 10. So 10, comma 10. B, we're going right 10 up 20. So 10, comma 20. And C, we're going right 15 and up 20. Now, in this problem, our scale factor is 2/5. So I'm going to take my first ordered pair, 10, 10. So 10, parenthesis, 2, divide by 5, side arrow, close parenthesis. So that would be 4, comma 4. So my next coordinate, this would be a 4, comma. Let's see what, if I edit this expression here, I'm going to delete the 10 and change it to 20. 20 times 2/5 gives me 8. All right, now change that 20 to a 15 times 2/5 gives me 6, and we already know this is 8. All right, so let's draw our new figure at 4, 4. We have A prime. At 4, 8, we have B prime. And at 6, 8, we have C prime. So let me connect this straight as I can. So there's our reduction of our original shape. So the rule here is just 2/5 times x, comma 2/5 times y. So when we transform these figures by dilation, it says describe whether each attribute was changed or preserved. So the size in a dilation is always changed. It'll get either bigger or smaller. But we're not turning the figure at all. So the orientation is preserved. And the orientation of the vertices is also preserved. They're still going in the same order. So it is also preserved. Okay, we didn't rotate anything or turn it, so we're all good as far as the orientation of the figure and the orientation of the vertices. All right, example 2. For each dilation, list the scale factor and an algebraic rule. Now, to do this, you're going to compare the new over the original, the new divided by the original. And you're going to pick one point. It doesn't matter which point you want to focus in on. I'll just focus on, here's my original B, here's my new B prime. Okay, so my original B, write that, original B was at 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5 was at 6, comma 6. The new coordinates of B are 1, 2, 1, 2. So if I take the new, it doesn't matter whether you use X or Y. So I'll just use the X value. I want to take the new and divide it by the original. So new is 2, original is 6. I can divide those both by 2 to get 1/3. So my scale factor here is 1/3. So the rule would be 1/3 x, comma 1/3 y. All right. Now we're going to do the same thing in problem B. We have A, B, C, D. The small quadrilateral was my original. And then A prime, B prime, C prime, D prime. That's my new shape. So to calculate the coordinates, I'm going to focus in on any point. However, in this one, I'm going to pick D because it's in the first quadrant. So I'm going to compare D to D prime. So original would be 1, 2, 3, 4 was 4, comma 2. The new, again, I'm focusing on D prime here, is going to be at 10, 1, 2, 3, 4, 10, comma, 5. So it doesn't matter whether you use the X or Y to make your ratio. So I'm going to take my new 10 and divide it by my original 4. Now I'm probably going to have to reduce here because those both have a common factor of 2. So 10 divided by 2 is 5. 4 divided by 2 is 2. So my scale factor that was used to create my new figure was 5 over 2. So my rule is 5 over 2 times x, 5 over 2 times y. All right. Now in problem C, they didn't give us the graph of the image. They just gave us a table of values. It's okay. It's actually easier. You do it the same way. Here's your original. Here's your new. So I'm going to, again, just compare the x's. It doesn't matter if you use x or y. I'm going to take negative 8 divided by negative 20. Let me write that down. I'm going to take negative 8 and divide it by negative 20. Now you can use your calculator if you want here. Negative 8 divided by negative 20. And that, whoops, I meant to write 20. And that's going to give us 0.4. I want to write that in fraction form because usually on standard tests, they're going to give you the scale factor in fraction form, 2/5. So our rule is 2/5 x, comma, 2/5 y. All right. In problem D, we have our original is this large square, and our new is this x prime, or this small square. What I'd like you to do right now is pause the video and try to get the scale factor and the algebraic rule. When you're ready to check your answer, press play. All right, welcome back. I compared 1 point. Well, actually, I think I'll just compare the side length. So I want to take the new side length, which is 1, and divide it by the original, which is 1, 2, 3, 4, which is 1/4. Now that won't reduce, so the scale factor was 1/4. Now you could have got that scale factor different ways. That's the way I decided to do it. So my rule was 1 over 4x, comma, 1 over 4y. And that concludes today's lesson, Dilations on the coordinate plane.